Example 4, drug screening and the basic multiplication rule. 50 test results from subjects who use drugs are shown below. Here we have the positive test results, which are 45, negative test results are 5, and the total is equal to 50. Now, in the first part of the question, it's saying if 2 of these 50 subjects are randomly selected with replacement, find the probability the first selected person had a positive test result and the second selected person had a negative test result. Now, with replacement, first selection with 45 positive results among 50 total results, we would have the following. The probability of a positive test result is equal to 45 over 50. Now, the second selection with 5 negative test results among the same 50 results, we would say that the probability of a negative test result is equal to 5 over 50. Now, we have to apply the multiplication rule. Now remember, the probability of A and B is equal to the probability of event A times the probability of event B, provided that event A has already occurred. So now we're going to translate this according to our question. We're going to say that the probability of the first selection is positive and the second is negative is equal to 45 over 50 times 5 over 50. So let's go ahead and do this on our calculator. So we have parentheses 45 divided by 50, and then times, we're going to use another parenthesis, 5 divided by 50. And again, we're using the multiplication rule, and that gives us 0.0900. Now, we're going to repeat part A by assuming that the 2 subjects are selected without replacement. So, without replacement, what that means is, without replacement of the first subject, the calculations are the same as in part A, except the second probability must be adjusted to reflect the fact that the first selection was positive and is not available for the second selection. So after the first positive result is selected, we now have 49 test results remaining, and 5 of them are negative. So the second probability is therefore 5 over 49. So again, here is our multiplication formula, and again, we're using without replacement. So now, again, using the probability of the first selection is positive is 45 over 50, and the second is negative without replacement. So because we took that one away, now it's going to be out of 49, and that's 5 over 49. So therefore, we would do the following. We'd say parentheses 45 divided by 50, close the parentheses, and then second parenthesis multiplication, 5 divided by 49, and then that gives us 0.091836735, and then rounding that to there in 4 decimal places, we have 0.0918. Now, important, the key point of part B is this. We must adjust the probability of the second event to reflect the outcome of the first event. Because selection of the second subject is made without replacement of the first subject, the second probability must consider the fact that the first selection removed a subject who tested positive. So therefore, only 49 subjects are available for the second selection, and 5 of them had a negative test result. Now, part A involves sampling with replacement, so the events are independent. Part B involved sampling without replacement, so the events are dependent. So here is our sampling. In the world of statistics, sampling methods are critically important and the following relationships hold. Sampling with replacement, selections are independent events. Sampling without replacement, selections are dependent events.